What we want to look at here is what's called 2D collisions, and what it is it's a little bit trickier. So I'm going to show you what I mean by that. Is we've got an object, just like the balls, we often use balls, hitting each other. So this might be the 4 kg, again hitting the 2 kg if you like. This one might be moving at, I don't know, 2 meters per second. But this time what happens is ball B flies off in that direction, maybe hits it slightly off center, and you've now got to work out what's going on. If this ball B, before the collision, so this is all before, has a velocity that's 0, then the only momentum we've got is the usual 8 kg meters per second that way. But now, afterwards, ball B now has, if ball B heads off at a, I don't know, a 42-degree angle, and it's got a velocity of, I don't know, 1.5 meters per second that way. So its momentum is 1.5 times its mass, which was 2, 3. So it's now got this vector going like that, P equals 3. Now, that one's momentum plus A's momentum must equal the total momentum before, because momentum's got to stay constant. So to end up with a vector like that, 8 going that way, if you've got a vector 3 going like that for ball B, total momentum, ball B, then we know that ball A, after the collision, must have a momentum like that. Now, this is not a right-angled triangle, so we would have to use the component method that I showed you when we were looking at vectors earlier on, or in one of my earlier videos, to work out the momentum of ball A after the collision. And once we've worked out the momentum of ball A, if we've got the momentum of ball A, that means we've got mb for ball A. Direction, and the length of that arrow will be its speed. The direction is what gives it its vector quality. If we divide it by its mass, we can end up getting that speed. Now, we don't probably, I might give you some questions on 2D collisions, but generally they're the more difficult questions at level 2, so we don't always do them. Now, let's just get another sheet. Going back to that, actually, while I've still got that, how would you work out that vector? Well, when you want to work out the sum of vectors, remember the components, horizontal component, vertical component, horizontal, vertical, and you just get your new vector. That would be the red vector, horizontal, vertical. Use Pythagoras to find out the length, and use the inverse tangent to work out the angle. So you can do it all the component way. I wanted to just talk a little bit about those collisions, though. When a ball hits another ball, like that, A hits B, and you get this momentum. You can calculate something called change in momentum. So if ball A had a momentum like that before, that's ball A, or the momentum of ball A before. If the momentum of ball A after is like that, then what's its change in momentum? Well, change is always final minus initial. Now we've said the final was like that, so change would be like that, but minus initial, we have to add the negative of the initial vector, and the initial vector was this one. So the negative of it is the arrow there, and we've got to add it head to tail. So that would be PF minus PI. This is all for ball A. And that means delta P will equal that, right? So that's our delta P. So that's our change in momentum for ball A. Now, you should remember what I said about change in momentum with that first introduction. If ball A has a change in momentum like that, that's ball A, ball B must have an equal and opposite change in momentum, which would be that. Right? This is the thing about collisions. Now, change in momentum is brought about by a force. So we're going to find that change in momentum, and this is the formula for impulse. This is how we'll bring it about. Impulse is force times delta t equals delta p. We'll talk about it a bit more in another video. But what we're basically saying is that change in momentum divided by change in time is equal to the force. So if I divide both these by the change in time, which was the time for the collision, I would now have a force vector. And the forces are equal and opposite, as you can see. So in a collision, you have an equal and opposite change in momentum, and therefore an equal and opposite force. We'll talk about this impulse after this. All right, stuff.